This is a talk about TypeScript, but it's predominantly around infrastructure management of using a tool called Pulumi. This is not a sales talk, okay? Everything you can see today in this talk is available open source. You can take it, you can play with it, you can do whatever you want with it, and you do not have to pay the company a single penny. Okay, so it's not here to sell you on a product, it's here to show you on a specific way of actually working. I'm not a salesperson, I'm an engineer on the tool. I've been speaking about infrastructure management in the industry for quite a few years now because before this I used to work at the rival product. So yeah. So in the cloud right now, we are going through a huge transition. Now, if we think of the bell-shaped curve of adoption, then it used to be a case of the people who were early adopters of the cloud have moved on in a huge way. But we have a certain set of phases through the cloud. So we have V1. And a V1 cloud infrastructure is pretty much a replication of what you had in your physical data centers. Okay, you have database servers, you have compute servers, and they talk to each other using security group rules or NAT rules. And you don't take advantage of any extra services or interconnected services as you go through. Once you've gone through that, you sort of move into this ecosystem where you're in a very transitional style architecture at that point. Now, you're starting to take advantage of maybe some hosted tools. Maybe you've mixed in like a PaaS database and some compute nodes and maybe a load balancer in there, but you're very much in this flux state. And then you get into this idea of like a V3 architecture, and some people there's different names for this. So we call it within Pulumi, we call it a modern architecture, a fully dynamic architecture. You've probably heard things like cloud native, microservice-based architectures, all these different things. Now, this is really bringing together lots and lots of different pieces within your cloud. So you could be taking advantage of an orchestrator like AKS or EKS or raw Kubernetes. You could be taking advantage of machine learning, batch processing, analytics, lambdas, storage buckets, and all of these different things come together and playing a part in actually the makeup of your system. Now, unfortunately, there is a management overhead with all of these traditional systems, okay? Now, if you're in the V1 style architecture, you probably have seen people still using traditional config management style tools. So, maybe Puppets and Chefs and Ansibles and tools like this, okay? Things where they bring the systems up. Once they're up, they don't have to destroy them all the time and recreate them. They can manage them when they're online. As you move through the various stages of 2 to 3, you then actually things have to become a little bit more immutable because all these different pieces work together and they actually have to understand where everything is. Now, for us, we believe that we're a modern infrastructure as code tool that allows you to create and develop your infrastructure on any cloud using modern languages. Okay, it's 2020. I'm not here to slag off JSON or YAML or DSLs, but it's 2020. Okay, we need to be thinking about the benefit that they give us compared to our normal development workflows. The rise of DevOps has made us all very aware of what our industry is changing and the trends that's happening in our industry right now. So we have developers who are starting to understand more about infrastructure in the cloud. We have operators who are starting to understand more about how development technologies are put together. And very recently, we've started breaking down these silos, and the teams are actually more fluid than they used to be. You now, of course, depending on the circumstances within your company, if you're a banking sector or an insurance sector, something like that, then of course you may have to have specialist teams because of certifications that you have to achieve within your company. But traditionally in normal web shops or e-commerce style systems, you're starting to get into this area with people starting to know and work in each other's style jobs. Now, for us, we believe there's a pipeline. So you can define your infrastructure, you can review, you test, you version it, you have your continuous delivery workflow, you can enforce your policies and practices, and then it actually becomes everybody driving towards the same thing. Now, this is all in the era of infrastructure as code. Anyone not heard the term infrastructure as code? Excellent. You haven't, or you have? You have. Okay, good. So infrastructure as code, just as a very fast recap, is we no longer SSH or RDP in the machines. Okay, we no longer go to the web consoles of our various clouds and click buttons to make things happen. Okay, because when we do that, it's error prone. When we do that, we don't remember what we've done. And if you have to do that 10 or 15 times, very quickly you make mistakes going into the system. So you declare your infrastructure as a block of code. Now, it's not what we would look at, and you look at infrastructure as code in that regard. Usually, you would look at it as something like a CloudFormation template or an ARM template or something like Terraform. So we're trying to reimagine how infrastructure as code is actually working. Why do we have to do this infrastructure as code in general? Because it's automated, it's repeatable, and it actually is predictable because it gives you the changes. It's going to tell you what the changes are before it applies them. So no longer do you have to just understand what's going on. I have very few slides. We're just going to go to demos very shortly, okay? Because it's better to show you with demos than anything else. Now, boring. We actually are starting to believe that infrastructure as code is more of the traditional style architectures of where you have the declarative DSL style syntaxes. And because we're using languages, and we can take advantage of IDEs and testing and refactoring and all the different things that goes with the language, we're starting to believe that what we're having is infrastructure as software. Because in times gone past, developers were very lucky because maybe 12 to 15 years ago, the rise of developer tooling went off the chart and developers started to get a lot more productive. Infrastructure engineers and traditional DevOps people and traditional operations engineers haven't had that same exposure to new tooling until maybe the last 2 or 3 years. So things are changing, and now the attitudes within the ecosystem, within the industry, are changing in a huge way. Now, we provide base providers on top of the clouds, but then we always give you on top of that like a set of patterns and practices libraries that we believe are best practices, and that's actually allowed us to create what's called Crosswalk. Crosswalk is an opinionated set of APIs that are built on top of the various defaults of the cloud. So for example, Amazon, when you go to the Amazon console and you click create a new VPC, it asks you 3 or 4 questions and it will understand all of the different pieces under the hood of the VPC that it needs to create. We have been able to encompass that in a simple library, which is called Crosswalk. The same thing can happen for a load balancer, the same thing can happen for a Fargate instance, or so on and so forth. Right now, we support Crosswalk in 2 of our clouds, okay? Or 2 of our major providers. The first one is Amazon, because it's our biggest provider by a long way. And the second one is Kubernetes, because Kubernetes is just this huge wave of hype right now that so many people are using, but a lot of people, once they actually start adopting it, can actually have some pain. So we're trying to make life a little easier for the users of Kubernetes. Now, infrastructure as code. We define the end state of our resources. It is declarative, okay? Even though it is using languages, real programming languages, it is declarative. Therefore, it will understand state, okay? So if you ask it for a security group and an instance that's related to that security group, it will understand that it has to create the security group before it creates the instance. If you don't have any relationship between the code, it will literally run down the program piece by piece by piece and run it, okay? So it understands, and it understands the differences between what you have declared here and what is currently in your cloud. It's a real language. Because it's a real language, you can take advantage of conditionals. You can take advantage of splits and maps. You can take advantage of loops. You can take advantage of all of these different pieces. Okay, you can refactor things. You can put them behind APIs that make life easier for people. We have our multi-provider workflows. For those who use current infrastructure as code tools, a multi-provider workflow is not a new thing for you. Okay, if you're stuck with CloudFormation or ARM template, stuck is the wrong word. If you're predominantly using ARM templates or CloudFormation and predominantly using that single cloud, then you don't need to care about multi-provider workflows because of the fact that you don't go outside of that space. But for example, what this will allow you to do is it will allow you to create an S3 bucket. It will allow you to create the deployment of an app that is actually stored within the S3 bucket, and it will actually use the container. We can package things up because we're not in the era of monoliths anymore. Again, it's 2020. Please take care with your infrastructure. It is real code. And lastly, or not lastly, I apologize, we can definitely start to take advantage of testing our infrastructure. Now, testing of infrastructure is not a very well-practiced discipline within our industry right now. I will show you a demo of actually how we can test our infrastructure after the fact. And I will also show you a new approach that how we are trying to do it within Pulumi that will allow you to mock the cloud, and you don't even need cloud credentials on your laptop while you're developing this infrastructure application. So we're trying to do better in the testing area. And then lastly, and this one is one of the most important things for me, this is code. Because it's code, if you use a tool that has an API or an SDK, you can talk to that API or SDK. You don't need to have people create providers for you on top of that. So for example, we have a Kubernetes application, an application that is hosted within a Kubernetes cluster. We want to deploy a canary of 3 replicas. After we deploy those 3 replicas, we talk to our Prometheus library. So under the hood in the check app metrics API call, it's actually talking to your Kubernetes, your Prometheus cluster, and it's getting the results of all the pieces of information that it needs. After we get the check back, and the check passes as expected, it can continue to the next set of replicas. You are not having to break down your workflow into, let's deploy 3, let's manually go and check the resources or check the results, and then let's go back and deploy the next 10, okay? It can do this for you because it is actually code and it is talking to an API. This is one of the benefits of what we have compared to any other tool out there. And then lastly, the most important thing for me, because we are extremely bad in industry at secret management. We are terrible at secret management. In fact, there's a very well-known cloud company that actually made a news release last week that they released the conversations of 250 million customers between themselves and their customer services because of an open Elasticsearch cluster on the cloud. Okay, we are just bad at this stuff. So traditional tooling is not very good at this stuff either. So because it's not very good at it, it makes it harder to manage our secrets. So we're actually trying to build secrets in. So for example, when we set Pulumi configuration values that you can read within your application, you can do --secret, which actually uses built-in Pulumi KMS in order to encrypt it if you're using the SaaS. You can pass in your own secret provider, which will be AWS KMS, Azure Key Vault, Google KMS, or you can use HashiCorp Vault, and it will store your secrets there and encrypt them in that fashion. Okay, and I will show you a demo of this as we go through. Let's just go straight to demos. Any questions so far? Everyone just want me to just be quiet so we can all leave? Okay, cool. So Pulumi is predominantly a CLI. And if I run the command Pulumi, that's not very big, I apologize. If I run the command Pulumi, you will get a lot of information that's there. The most important thing to get started with Pulumi is that we give you a new command. Okay, so if I say Pulumi new, demo 1, and now if I say Pulumi new, let's cd to demo 1. Now if I say Pulumi new, it will ask me what type of application do I want to scaffold. Does it need to be Amazon JavaScript, Amazon Python, Amazon TypeScript? Does it be GCP, Kubernetes, whatever? Today we're going to use AWS TypeScript. I will show you an Azure example as well, just so that people who use Azure aren't left out. It doesn't matter which cloud we're using. This is for the purposes of demos, and I have pre-created the demos. Now it will ask me what we want to call things. Let's just call it Project 1. Give it a description, it's fine. And then it asks me this idea of what the stack is. Now, stacks are a very interesting thing within Pulumi. For those who have used Terraform, it is the equivalent of a Terraform workspace. okay, which you are not enforced to use until you want to use them, whereas Pulumi enforces you to use stacks right up front. Because stacks can be used for multiple things. It can be used for different environments, but I've also seen people using stacks for different developers. So each developer has their own stack that they can bring up and destroy the resources independently of each developer. And I've even seen people using stacks as a way of creating different tenants of the same application for a different customer. Okay, so it's a way of actually being able to segregate a number of resources for a specific reason. So this person had a multi-tenant application, and had a database, it had different things, and each customer had their own setup of exactly the same infrastructure, so they had a different stack per customer, and each stack had its own secrets that went with it. So for now, we're just going to say dev because that's the default. And then lastly, because it's an Amazon, it's going to say what region, and we're going to say EU West 1. Now it's JavaScript, so it's going to install the world. So if you just give it a second. But I can go to my UI, and I can see that it has now created the scaffolding of an application. It has the Node.js modules, of course. It has a git ignore file. It has index.ts, which we'll come back to, package.json. It has the pulumi.dev.yaml, so that it segregates the configuration for each stack away from each other. It has pulumi.yaml. You don't need to worry about that right now. We're actually questioning internally if we even need that anymore. And then it has, because it's TypeScript, it has like best practices around TypeScript config. Now, if we look at index.ts, we can see that it has actually scaffolded the Pulumi application. It brings in the correct imports, and it scaffolds an S3 bucket. Now, everything inside Pulumi AWS is actually packaged away, modeled. So if I say AWS, I can actually see that I have RDS, S3, IAM, Lambda, CloudWatch, EC2, blah, 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 blah. Okay, so everything has its own sub-package relating to what it would be inside Amazon. But for now, we're actually just going to use bucket. And then when we create the bucket, because we can just export the IDs based on the back of it. Now, no YAML was harmed in the making of this demo, but you can actually see it's a little bit easier to read than writing YAML or a DSL or JSON. And of course, I'm in a real language and an IDE, so I can go and have a look at exactly what's in there, and I can step in and have a look in the API and the arguments and the different types and all the documentation that goes with it. So we get everything that we need. A resource in Pulumi has 3 parameters. Okay? It has a name, which is an auto name that's used as part of the resource naming convention inside the state. It also has arguments. So this is arguments specifically relating to the resource itself. And the last thing it has is what's called custom resource options. Now, custom resource options is for, I can actually show you a demo of that in a little bit. It allows you to specify specific information, example, protect true. Now, this means that this is a statewide protection, and regardless of what you do inside Pulumi, this specific resource will actually never be deleted. We do things slightly different to other tools. What I mean by that is that by default, everything has an auto naming. An S3 bucket, we're going to call my bucket, but when we actually deploy that to the cloud, it doesn't actually end up being my bucket, it's actually my bucket dash random string. The reason we do this is there are a lot of operations in the cloud that do not allow you to create the new version of the resource with the same name as the old version of the resource. A storage account, a resource group in Azure, an S3 bucket, a launch configuration in AWS, and so on and so forth. So it will actually allow you to create new ones before it deletes the old ones. But you can turn that off at any time by overriding the naming convention. And by saying in bucket, for example, I just know them off the top of my head, I can actually say NDC demo 1. And it will now explicitly call the bucket the NDC demo 1. Now, if I go back to my terminal, and if I run Pulumi up, it will try and diff what I have locally compared to what I have in my cloud, and it will tell me what it's actually going to do. So the first thing it does is it tells me it's going to create the stack, and then it's going to tell me it has to create the bucket because it doesn't exist, and I can look at the details here. Now the structure of our URN is actually extremely simple. It goes stack, project, stack, project, resource, and then the naming convention. Okay, so it doesn't actually have in there that it's called NDC1 because that's an implementation detail. That's not a Pulumi level detail. So it is very, very, very simple. And because of that simplicity, as long as you keep the resource name the same, so for example, my bucket, and it stays inside the dev stack in the demo project, you can refactor that code till your heart's content, and you can move resources around, different packages, different folders, whatever you want to do. It doesn't matter. And then we can say yes, and it will actually go, and it will deploy it. Now I told you infrastructure as code, and you can rerun the same code again and again and again. So therefore, just to show you that it's an immutable operation, once it has been created, Pulumi knows about the state. It is creating, as you can see right now. And it says it's created, and it tells us that the bucket name is created as NDC demo 1. And if I Pulumi stack export, I can see the state that it has actually created, and it has all of the different pieces of information that it has created my bucket within. Now, of course, I can run the same command again, which will be Pulumi up, and it will tell me that there are no changes that need to happen here. Any questions? Awesome.
One question. What is your license?
So the question is, what is the license? The license is Apache 2. So everything I'm showing is open source. You can fork it, do what you want with it, build whatever applications you want to on top of it. Even if you don't pay for the SaaS, you can still do that. It doesn't matter. It's Apache 2. Okay, and you'll see that there's no resources unchanged here. So we can say yes, and it's actually not going to do anything. Or we can have a look at details of exactly what it needs to do, and you can see everything's exactly the same. So let's just say no.
But they still destroy resources that are not mentioned in the code.
Excuse me, say that again.
Will it destroy resources that exist?
Oh, great question. So the question is, can Pulumi destroy resources that are not existing and managed in Pulumi? The answer is 100% no. If it's not in the Pulumi state file, it will not touch anything in your system. So I know this off the top of my head because I had to write an AWS Lambda that cleaned up over 500 VPCs this week because my Pulumi applications and my other developers' applications, we were just pushing stuff up there and nobody was able to delete anything. So we were just hemorrhaging money. So yes, so it will not destroy anything unless it's in that state file right now. Okay, and that's the most important thing that you need to know. Even if you have manually created something as part of the bucket, it won't be able to destroy the bucket because there's something in the bucket that you haven't managed. Okay?
Where does the state get stored?
Oh, great question. Great question. Where does the state get stored? By default, it stores in the Pulumi SaaS. Okay, so when you sign up to Pulumi, it will sign you up with a new account. You don't need to store it in the SaaS. If I say Pulumi, who am I? -v, you will see it's user stack 72 in this specific backend. I can say at any time Pulumi login, cloud URL S3, I can say GCP, I can say AZ blob, so on and so forth, okay? All of these backends mean your stuff is not even being pushed through the Pulumi application at all. The CLI is completely unconnected from any tracking or anything that you do. Okay, so I'm telling you that for the purposes of just the demo today, I'm logged into the SaaS, but you can 100% use an S3 bucket and it works exactly the same. No differences. Now, I told you I can create tests. And this is now where we start to get into the power of the language. So I'm going to create a new folder called specs. And then I'm going to create a new file called index.ts. And in this file, I'm going to write mocha test spec. Okay. And what this mocha test spec is just a mocha runner. Okay. Mocha is a JavaScript testing framework. It doesn't do anything special apart from finds all of the files in the current directory and runs them it runs the tests for each one as long as they're not called index.ts. Okay, it's very simple, very Very easy. And you can see because it's in my IDE, straight away it's telling me, hold on a minute, I can't find this module. So then I can just go, I know I have to do a few installs, npm install Mocha, which is just the testing framework. Then I need to install Chai, which is allowing us to actually do a BDD-style behavioral way of specifying our specs. And those are the JavaScript libraries. Because I'm using TypeScript, I have to npm install @types Chai and @types Mocha. And if we go back to my application, you'll see my ID is actually, and everything just goes green, and I understand that everything is as expected. Now I can create my spec in here, and I can actually start to create things that look like real understanding of what my infrastructure is. And if I write bucket spec, I can say, look, that the Amazon bucket that I have created should have that specific bucket name. It should be in this location, and it should have private ACLs. Now, this is an extremely simplistic example. So let's pretend that you had an RDS cluster, which is a hosted database cluster in Amazon. You can say things like, it must not be available to the public. So it must be in your own private VPC. It must not have access on its security group via port 80 or whatever the port that you will be using. If you're following GDPR in Europe, which is, I don't know what happens after Friday, but maybe we'll see. But if you're following GDPR, best practices around GDPR, you can say things like the resource must be within this specific location so that you're not leaking information across different boundaries. And we can actually start to take advantage of being able to run the test here. So I need to do two things. One, it doesn't understand what my bucket is. So I'll find that and I'll export the member. And then I just actually need to install the test runner. And I can actually say my bucket. And my bucket just needs to be bucket. And then lastly, I can just say run tests. And because I'm in my IDE, you'll see it's actually immediately imported everything that it needs to import. And if I go back to my Pulumi up, and I'm just for the purposes of skipping, to make it a little faster, I can say yes, which means don't ask me for confirmation, and -- skip preview. I know that nothing has changed from before, so it's actually just going to go straight to running the tests. And you can actually see in the top right-hand corner of the test, somewhere around here, it'll actually start to say Mocha test runner in just a second. There we go, running our Mocha tests, and we get the full output of our Mocha tests and what has passed and what has failed. So it's great to be able to show you what happens after the fact that resources have been created. Now within Pulumi, we have been hard at work of being able to allow you to write real test-driven development, which means that we can start to take advantage of mocks. So this is something that's not quite hit master yet. There's a pull request open, but we can actually start to mock what the cloud returns. So for example, is if somebody within their application is asking for a security group, here's the return of a security group, here is the return of an instance, and then within their application code, they can say, define in our infrastructure, all of the servers, so infra server, which would be like an EC2 instance, it must have tags, and then we can actually run tests, making sure that the tags are expected. When you run tests in this way, you don't even need cloud credentials, which of course is a huge cost saving because people spend a lot of time spinning infrastructure up and down, which costs a lot of money. And of course, it costs a lot of developer time. So if you can eradicate that time in order to bring resources up and down by giving them a direct output of exactly what's going to be there, then life is a little easier. And we support the same thing in Python because we have my mocks in Python as well, and so on. So this is something that we're actually extremely aware that people want. And then lastly, I can say Pulumi destroy, and it will actually tell me what it's going to destroy. And you'll see the only thing it's going to destroy is this entire bucket, okay, and the stack that it created. And I can guarantee you, because this is our company test AWS account, we have hundreds and hundreds of buckets that are there, but it's only going to delete these two. And of course, you can run like a charge proxy or something, and you can actually watch the request that it's making to delete it just to make sure that you're happy with it. So we can say yes. Oh, excuse me. And we can see it's actually going to delete. So let's go to a more interesting example. That's just the basics of being able to bring Pulumi up and down and watch it does. Question?
Can you create a Pulumi project from an existing?
Great question. Can you create a Pulumi project from an existing infrastructure? Is that an infrastructure that you manually managed in the cloud or something like this? Yes. The answer is 100% yes. Because we have this thing in the custom resource options called import, and you actually point directly to the URN of the piece of information that you're going to do, and it will import that into Pulumi state. It will tell you before it imports if what you have specified in your code matches what is there, and it will try and force you to not import it unless everything is identical. I can show you a demo of that actually offline, okay? Okay? I'll get to it. I just have like 5 more demos and then I'll get to it. Okay, so let's create a new project. Make their demo 2, cd demo 2. And I'm going to Pulumi new, and instead of waiting for the wizard to come up, I'll say AWS TypeScript. And I'm actually going to force it to create an AWS TypeScript. Demo 2 is fine, description is fine, dev is fine. And again, I'm actually going to make it in EU West 1. Trying to be a little patriotic to be in Irish, but and it'll have everything that's there. Okay, so let's go to our next demo. This demo will actually show us how we can declare infrastructure, then refactor it as we go. So let's create what's called like a different piece of infrastructure. The first thing it's going to do is this is again within Amazon. There are pre-created images that you can spin up your virtual machines within Amazon. The same exists for all of the clouds that are there. Okay, this will go off and it will get a specific version of an AMI that matches the filter that I want, and by canonical, this is an Ubuntu 18.04 application, and it will actually do this first before it does anything else because this is a requirement. Okay, then it'll create a new key pair, it'll create a security group, and it'll create a web server. Okay, now you can see that I have forced explicit relationships within this application this time. Firstly, I am referencing ubuntu.id. Secondly, I am using ssh key.keyname. And lastly, I am using securitygroups.name. Now, one of the biggest banes of my life as a developer used to be magic strings. I hate them. Within our application code, we don't put up with magic strings anymore. We use constants everywhere. So our feeling within Pulumi is, why should we put up with magic strings? So an instance type in AWS has a magic string. But we have been able to create syntactical sugar that's a union type in TypeScript that allows that to be taken away. So for example, instead of T2, I can say EC2 instance types dot and get all of the available instance types in here. So let's go back to T2 small. And then we have the same for RDS, excuse me. And we can see all of the different pieces of RDS. But look, immediately, my application has said, wait a minute, I expect, actually, let me just choose one. And my application says, I expect an EC2 instance type, not an RDS instance type. So it actually understands the differences between them. So it's actually using the power of the language engine in order to do that. Rather than what would usually have happened where we would have had to deploy our infrastructure, wait for the infrastructure code tool to come back and say, wait a minute, I don't understand what that string is. Okay, so that's usually what happens. Now, it's JavaScript. Any JavaScript developers in here? Okay, I apologize for saying this. JavaScript allows you to do mental things, like literally mental things. It's why I actually like it for these demos. Okay, so for example, I can say let web servers equals an empty untyped array, okay, which within infrastructure is fantastic. Okay, now I can then say for let x equals 0, x is less than 100, x plus plus, and immediately I'm inside a loop. Okay, and now of course it's a real loop. It's not a loop that's been forced in the YAML or DSL or something like this. And we can actually say web servers dot push. And instead of creating a new instance every time, we can actually push a new EC2 instance into quit. There we go. We can push a new EC2 instance into that array. Okay, the only thing that we have to do is each resource within Pulumi has to be uniquely named. So I can say $X. Okay, so we'll get web server 0 through web server 99 because of the loop. Now immediately, this web server doesn't exist anymore. So I can actually say web servers dot map and use a small lambda in order to get all of the public DNS out. Now I've used the power of exactly the language and the ID in order to actually build this, where I've taken one statement and very quickly been able to refactor it into 100 VMs, just using a simple loop and just using different things. And then we can even take that a little further. Let's pretend within your organization you don't allow specific pieces to be set, and developers actually need to be quite constrained. So we can actually create, let's pretend this is a new package, of course, that's been created and distributed around. Let's create a new file called webserver.ts, and webserver.ts will be a web server class. And we just move in the security group and the key pair down. And because it's real language, we can actually export the class. The class has a constructor which takes parameters, and the class returns a read-only instance of a VM. Okay, so if I go back to my index.ts, instead of pushing a new EC2 instance in every time, I can actually say a new web server. And I know that I need to pass in ubuntu.id. And I know I need to pass in, I apologize. So the first thing I need to pass in is web server dash $X. Now notice immediately that the resources are still named the same as they were in the loop before. Nothing has changed in the name, so nothing will recreate. I know I need to pass in ubuntu.id. And then lastly, I can actually pass in EC2.instance type, AWS.EC2.instance types T3 large. Now we've hidden away those layers of abstraction from developers who don't care necessarily about it. They just need to ask for a number of web servers. They don't care about the details of how a web server is created. And then we can actually see that from our Lambda, this is not wrong, this is not correct anymore, because it used to be an array of web servers which were of type EC2 instance, but now they are actually a list of VMs which under the hood are a list of EC2 instances. So I actually need to say x.vm.public DNS. So immediately we've been able to clean our code up, refactor it away, and there's no problems here. So it's extremely clean in how I can do this. Any questions? Awesome. Means there will be a test. Now let's make another one. Now I promised you that secret management was something we care a lot about. So let's just create a Pulumi new TypeScript application. And secret management is something that's extremely close to my heart because I'm an operator at heart. I'm not a developer. So we can go back. Actually, I just have one more package that I need to install as part of this. And if I npm install @Pulumi random, just in order to actually get like random data that we can actually use. And if I go back to my IDE and into demo 3, what I'm going to do right now is I'm going to create like a password. I'm going to fake the creation of a password. Okay, and I'm going to say password1 equals new random password. 1 second, I need to do the correct import. Import star as random from @Pulumi random. And then I have access to the random password, and I'll say password1. And I'm going to say length equals 30. And I'm going to say special is true, so we actually get like a real representation of what a password would look like. And if I export constant secret value equals password1.result, and if I go immediately and run Pulumi up, we will actually get a real password out on the screen. Now, this is what other tools do. And usually when you have other, like using traditional infrastructure as code tools, you need other supporting tools in order to help you manage the secrets with it. Okay. Within Pulumi, that's not really the case. So if I now say constant password 2 equals new random.random password, and I'm going to say password 2, and again I will give it length 30. Oh, excuse me. And again I will give it special as true. But this time in the custom resource options, I can actually tell the Pulumi engine, regardless of what version, if you're using the S3 backend or whatever, it doesn't matter. I can tell the Pulumi engine, I need to encrypt the pieces of information that come back from this object. Okay, so I know that the output from here is called result. So I actually want them to encrypt the result and see what comes out. Okay, and then if I export our const, secret value 2 equals password 2 dot result. Now, what would usually happen here is that it would come out as a secret in the output just because of how it works. We can see the secret object right here. But even within the Pulumi stack, we can see that it's actually been encrypted correctly and stored correctly. So the state is able to be checked in because it's the Pulumi engine that knows how to decrypt it based on how you have set up your project. Okay. Now, of course, that's within code, but there's another way that you can actually do this. So Pulumi config set, and we're going to say the value is called my password, and the actual value that we're going to create is my password 1234. Now, this is usually how people will create passwords within variable files, and if we go to our variable file and we have a look, we can see it's actually stored in plain text. But if I run exactly the same command with secret, which uses Pulumi KMS, like a KMS value that's been assigned to your project from the Pulumi SaaS, run exactly the same command, we can see that it's immediately changed to a secure string. Again, this is very safe to check in. There's no problem. Okay, you don't even have to use Pulumi SaaS, Pulumi KMS. You can say secret providers, and you can pass in your own KMS ID, or so on and so forth, and it doesn't matter. As long as the credentials that you're using from the Pulumi CLI has access to it, there's no problem. Okay. Now, Pulumi doesn't know about those credentials. They're not stored in the state in any way. Just to show you that that's actually the case, see, it's actually using a secret service, and it understands about the state, but no actual secrets are being stored. No keys, no AWS keys, nothing is actually being stored in there. Okay. Questions on secret management? I'm seriously running out of time. Okay, 20 minutes. Make their demo 4. Any AWS users here? Who likes IAM management in AWS? Nobody. Right. It's terrible, okay, because it's JSON. Nobody likes JSON, really, sorry. Okay, so we're going to say Pulumi new, AWS TypeScript. And I'm going to show you that because we're in a language, we've created syntactical sugar helpers, APIs across the top of IAM management that makes life a lot easier. Really a lot easier. You will not see any JSON on my screen at all, I hope. Maybe no. You might. You might be first. I can't remember. Okay, so let's pretend that we have to create an assume role policy. Can anybody tell me the JSON structure of an assume role policy? I've created thousands of them, and I still don't remember. And every time I have to look at documentation, what's the order of the strings? So we can do this in a little different way. So I am going to say, and it is called IAM role. So we have a role, okay, and we need to create an assume role policy. And usually an assume role policy would be, you would actually have to open up a here doc, and you would have to paste the JSON, not with us. Now, if I open up the correct demo, there we go. Why are you not working for me? Wrong one. Okay, perfect. So we have created this idea called aws.iam.assumeRolePolicy for a principal. Okay, and all we have to do is pass the service that we actually want to take in here. So in this case, I can say service is ec2.amazonaws.com. Boom. That's your assume role policy. Under the hood, Pulumi is emitting the correct JSON because it's a standard JSON spec and a standard JSON format that it needs to do, and it will pass it out. Now, let's pretend that after that role, we need to attach more policies into that role, okay? And we have named policies. Okay, and if I say I am role extra policies, where are you? Where are my live templates? There we go, that's the reason why. Give me. Okay, let me try and copy them from my iPad here. It's thinking about it. Oh, it's worked. It's worked. Okay. So we usually have strings that look like this. Okay. Now again, we have made this a little bit easier. aws.iam.assumeRolePolicies, .manage policies, and as soon as I say dot, we will get every one of the existing managed policies that are currently within Amazon. So let's just pretend that I need that one. So I have these 4 policies that I need to attach to this role. All I need to do is let counter equals 0 for const policy in manage policy ARNs. And then I say const RPA, so role policy attachment equals new aws.iam.role policy attachment. And here we're just going to call it RPA. It doesn't matter about the name here. And we're just going to say count plus plus. So every time it goes through, it does that. We'll say our policy ARN will be policy. Excuse me, I have a typo here. It will be policy. And we will say the role that it is attached to will be our role. Now, I have not only written a role and an assume role policy, but I've also attached a further 4 roles to it, and there's no JavaScript or no JSON on the page. Okay, so it makes life a little easier. But we can even go a little further than that, because what we can actually do is let's pretend that we have bucket policies, okay? Because bucket policies are a real thing that people need to adhere to. So let's just say const my policy, which is an aws.iam.policy document, because we have created a strongly typed object that represents what a policy is. Policy has specific pieces to it, and we can actually say, in our case, it's a version, and the version of the policy can only be these 2 values because we have autocomplete in here, so let's just choose 1. And we know that it needs to be a list of statement objects, and we can actually see and we can get hints and details of exactly what it's missing. And all I need to do is I can just say SID, which will be add perm, and I can say effect, which will be allow, and I can say principal, which will be a star. Please don't put stars in your policies. It's extremely bad practice, but for demos it works and saves me time. So for here, we're actually just going to say S3 star, so just allow everything to do with this bucket, and I'm not going to give it a resource just because they're long to type. Now there's my policy document, and as soon as I say constant bucket equals new aws.s3.bucket, I'm just going to say my bucket, I can actually say that the policy is my policy. So I've again created an AWS policy, no JSON at all, and attached the policy to the bucket as expected. So that's like the basics. Now we can really take this a step further. Anybody use Kubernetes? Okay, cool. So a customer came to us and asked us to do a proof of concept. Okay, they said, we have a number of Kubernetes architects who know how to build Kubernetes clusters, and we have a number of developers who need to be able to spin up test Kubernetes clusters to deploy their applications into that don't know how to build Kubernetes clusters. Can we, as a company, help them do something? So the answer was yes, okay? Because what we did is we created a multi-cloud Kubernetes cluster, okay? So in these 14 lines of code, each developer could spin up their own AKS cluster and EKS cluster. It would export the kube config, which is the configuration that allows you to connect to a Kubernetes cluster after it has been created to run deployments or run operations against it, or actually even monitor it and so on. But under the hood, this is actually an API, okay? So Pulumi has this idea of what's called component resource. A component resource is a way of being able to manage a number of resources as part of a similar operation. Okay? A Kubernetes cluster is a perfect example of this. Because in Azure, a Kubernetes cluster needs a service principal, an Azure AD application, it needs a resource group, it needs the role assignment to the service principal, it needs a virtual network, it needs a subnet, it needs the actual Kubernetes cluster itself, and you need to be able to pass in lots of different information. And then lastly, you need to be able to actually get a static IP in order to understand what the Kubernetes cluster is. Now, the company that we spoke to, their developers didn't know all of these different things were needed because they didn't care. It wasn't their job. It wasn't something that they had to worry about on a day-to-day basis. So just by giving them these like small snippets of code, they could then extend it and say, if I want to deploy my applications to all of the Kubernetes clusters in my multi-cloud, I would declare a new provider. Okay, so if they have GKS cluster, they would just declare a new GKS provider. Okay, they would pass in the kube config of the GKS provider. They would add it to the loop, and then as part of the loop, they were very simply able to deploy the same application to all of the multi Kubernetes clusters, and then find out what the URL of the application was at the end. So for developers, it was a lot simpler because they were able to hide away these levels of abstraction that they didn't care about. There's another demo I can show on this. There are a number of companies that want to segregate the work that allows developers to work independently of infrastructure changes. So for example, let's pretend you have a very large company and your company is SOX compliant. So because it's SOX compliant, only specific people can manage your network, other people can manage your database, and other people can work on your applications because everything is segregated away. So we were able to build a proof of concept that says, in order to build an AWS VPC, we would implement this class. Okay? And inside this class, it's doing all of the work. It's creating the VPC, the internet gateway, the Route 53 zone if you need some. It's doing all of the CIDR or the subnet mask calculations. Nobody can do that off the top of their head just because it's one of those things that you usually look up on the internet saying, give me the size of a /24 subnet so that I can understand what it does. But this does it for you. It has route tables. It has routes, and it will map all of the route associations. It will create the NAT gateways, and it will assign the NAT gateways to the route tables. And then lastly, it will turn on any VPC endpoints that it needs. It will turn any roles that it needs, and so on and so forth. These are things that developers within the company that we showed this to didn't even know existed because it used to be so hidden away from them. They were usually given a VPC ID that they had to hard code into their infrastructure code to bring things up. Now they can actually run their own test VPCs and actually be able to bring it together. Now they asked for a layout of a proof of concept that says we need an application VPC and we need a database VPC because you can't talk to the application, or you can't talk to the database directly unless you go through a specific security group which will allow access to nobody within the database apart from the DBAs. It's a normal requirement, okay? So we allowed them to create an application VPC, a database VPC, and because we're in a real language, we wrote an extension method called configure peering, which will actually do all of the VPC peering between the VPCs, okay? Again, something that developers just didn't care about. It wasn't there. It would have slowed them down. They probably would have made mistakes because it's not something that's their area of expertise. So then we were actually able to say, when they created a database, get outputs from the database VPC pass in the usernames and passwords. And then lastly, when they created the application VPC, you could get outputs of the app VPC, the public subnets, and then you could even do things like give me the DB instance port and the DB instance address. Now, one of the things that was very interesting for them was that they used to have a flow where they would actually deploy applications to ECS. Okay, now it tends to be that you have two different workflows for that. You would go to your CLI and you'd run Docker build, and you would then wait for it, and you would hard code what the image name is into your application code. Not with Pulumi. Okay, Pulumi will actually wrap Docker, and within the same application code, it will run the equivalent of Docker build, and you can actually see the Docker build happening within the same workflow and the same run. Okay, so we've developed these APIs across the top, which will actually allow you to pass in all the different pieces, and you can actually go the whole way down, which will actually give you the real container image. So life became a little bit easier as we went. And then even by creating these layers of abstraction, we were able to feed this back into our own system. Now, what I mean by that is, anybody use Azure Functions? Okay, cool. So for those who do not know, Azure Functions have a number of different resources that you need to create. Okay, in order to create an Azure function, you need a resource group, you need a storage account, you need a storage container, you need a zip blob, and you need the app service in order to actually run it. Okay, now we can wrap up those APIs. Okay, because they're not difficult APIs in order to wrap up. So if you go to github.com/pulumi/examples, every one of these examples are actually there, and you can go and actually play with them. But if I have a look at functions raw, this is a way of being able to deploy 5 different variants of an Azure function. Okay, so a .NET, a Java, a JavaScript, PowerShell, and Python. And we have created this idea called an archive function app. So you pass the resource group in, you just give it a folder location of where the code is, and it will actually zip it and actually push it up into your storage container, and then you just pass in the app settings if it's like a specific type. Okay, so under the hood, that is actually creating 7 resources. Very simple, very easy. And then we went a little more further because serverless has become this huge thing that people are really starting to do. So we thought it would be really cool if you didn't have to segregate your infrastructure code from your application code anymore, and you can actually embed it within the same flow. So there is an example called the, I don't know if it's this one. Where is it? Not that one. I apologize. Slackbot, there you go. So Slackbot does a number of different things. Firstly, it will create configuration, it'll create a DynamoDB object, then an SNS topic, and it'll actually declare some classes that you can actually push around strong objects rather than just strings or interfaces. And then we can actually say, give me an API gateway. When the API gateway has a path of /events and it's a method post, here is the Lambda that you are going to embed within your API gateway. And Pulumi knows how to take that code and actually turn it into a Lambda and push it into the Lambda. And you can actually do every piece of your application. You can do event callbacks, and then you can even have extension methods on when a message is processed within your SNS topic, here is the Lambda that you're actually going to run in here, and you can have your event callback request, and you can talk directly out and build all of the application code, the serverless application code within your infrastructure code. So this is when we're really heading into this V3 style architecture, where you have these modern teams who know how to do all of these different pieces that go with it. So for us, it's actually extremely interesting that we can get there. 5 more slides, and then I'll let you all go. Okay. So policy as code is a huge thing for us. Policy as code is the next evolution of what we're trying to do. Now, policy as code will allow you to embed workflows within your Pulumi apps that will stop you doing mental things like I told you earlier about leaving your existing systems open to the public. So you can do things like every EC2 instance or every resource must have a tag. Okay, because that's my pet hate in IT, when you have no idea who owns something and you don't understand why something is actually costing you money. So you can enforce it as a policy. You can enforce things like no security group rules are 0000. You can actually say, you need to be within a specific region, so that by default, everything in Amazon is in US East 1. So if you didn't realize that, you're creating resources there and you might not actually be able to within your company. And then you can even do things like the version of your RDS instance must be below a certain version of MySQL or Postgres. Okay? And we have a ton of people who are using these, and actually very happy using these. The most interesting case study for us is a company called Learning Machine. It's a most interesting use case for me because they turned 25,000 lines of CloudFormation code into 500 lines of JavaScript, which must have been a breath of fresh air for their infrastructure people. But for us, we really think that this is going to be the future of how people are going to program in the cloud. Amazon have released the CDK, which also shows that Amazon will allow you to use real languages in order to emit CloudFormation templates. I believe other tools will probably appear in the space just because it is going to be a hugely growing space. But for us, it's a massive thing. All I can say is thank you. I have some time for some questions if people do want to hang around. But if not, enjoy the next 2 days of the conference. Any questions? Question?